world, welcome back to another picoGym exercise challenge video. In this video, we'll be walking through the forensics challenge Wireshark 2222. Let's get into it. Can you find the flag? Okay, and they give you a shark2.pkpng file, which I have open over here. Let's go ahead and take a look at the protocol hierarchy. Two protocols that appear to be of interest are, of course, DNS and HTTP. Let's go ahead and look at HTTP first, since it's the easiest to look at. And we're going to sort by the line-based text data, because that's usually where stuff's hidden. And we're going to go ahead and follow the TCP stream. And you'll notice that this is a flag, but it's a red herring. Because if you cycle through these TCP streams, you'll notice that they all change for each stream that has this so-called flag in it, right? These are all red herrings, and they're not what we want to look at. We actually want to look at the DNS traffic. So let's go ahead and apply that as a filter. And if you look at the query names, you'll notice that they're kind of strange, right? You see that it says redshrimpandherring.com, which would make you think under normal circumstances that that's a red herring. But if you look at the first subdomain of the whole domain in these, you'll notice it follows a recognizable format, which is base64. And if we were to scroll all the way down, you'll see that there's a double equal sign. So it clearly is base64 that's taking place here, which we can obviously parse out and decode and see if it comes out to be anything plain text or readable. And we can do this in Tshark, which is, of course, Wireshark's command line utility. So as you can see, I have the file over here in Linux. The reason I'm not doing this in Windows is because there's a lot more user-friendly Bash utilities that you can use in Linux to help parse the data out than there is in Windows. Or at least I know more of them in Linux than I do in Windows. But regardless, let's go ahead and start up the command. We're going to do tshark tac r, which you use to specify a file, which is shark2.pkpng. Then we're going to parse by the fields, and we want the dns.query.name, right? Because if we scroll down, you'll notice down here that the name, if we were to apply as filter, you'll see that it's dns.query_name, which is what we want, right? We want that query name because that has the relevant data in it that we want to decode. Then, of course, we want to specify condition of dns.query_name is not empty, because if we don't do that, then it'll still get every packet, but it'll print out a blank line if the DNS query name doesn't exist. So we want to make sure we're only getting packets that actually have that field in them, and that field being not empty. So let's run that. And here we have a nice list of stuff, and you'll notice that there's a lot of duplicates and everything. But what we're going to do first is we're actually going to grep out the first part of the subdomain. And the way we're going to do that is we're going to do grep tac e for extended grep. And we're going to put in a pattern of caret, open bracket, caret dot, close bracket, and then asterisk. And I'll explain what that does in a second. So let's just run that command. And you'll see that the first part of the subdomain is, of course, highlighted, which means it got those, but it's still returning the rest of this, the strings for the subdomain, right? Which we don't want. We want just the subdomain, because we can't base64 decode this portion because it's not a valid base64 string. Now, tac e is just extended grep, right? We need to do tac o if we want to just return the highlighted portion right here, or the off-colored portion. Now, what the actual regex pattern does is it's saying, hey, start from the beginning of the string. That's what the first caret is. And then inside the brackets, the caret actually means match anything that's not a character set of whatever's inside the brackets. Now, under normal circumstances, the dot matches any single character in regex. But if it's inside the brackets, it's treated as a normal period, a literal period. So we don't have to escape it. And so basically, we're matching everything that isn't a period, so the first part here, of course, and then we're saying 0 or more of that, right? So we're getting everything up until where there's 0 or more periods, which is what the asterisk stands for. So the reason why it's not getting the rest of this, even though it's returning it, right, we care about is the highlighted portion. The reason why it's not getting the rest of this is because we're only matching up until where there's, you know, a period. Because if there's a period, then that's not part of the subgroup matching. So it's limiting everything up until the period. Because if it's a period, then of course it's not going to return that back as a parsed out string. So we need to put the tag O in so that we're just getting this portion and not the full string back. And there we go. Now we're going to pipe that into unique, right? Because we want to only get unique instances of everything. Okay, there you go. And then we're going to pipe that into base64 tag D, of course, to decode the strings. Now, at first glance, this may just look like a bunch of gobbledygook, but if you look closely, you'll notice that there's parts of the flag here. picoCTF, DNS underscore, exfil in leet speak, and so on and so forth, if you can make out anything else. So clearly, in the exfiltration of this data, it's throwing in a lot of just random base64 in here to kind of cover up the actual data being exfiltrated, which is our flag. So we need to come back to the Wireshark file, the pcat file, and look for anything that stands out in regards to certain packets that would contain our flag versus packets that wouldn't and are just clutter, right? Just fluff. So let's take a look at our DNS packets again. And if we scroll down, you'll notice that there's, you know, source and destination of communications between 8.8.8 and 192.168.38.104. Now, 8.8.8.8 is Google's subdomain, which is clearly not right. So whatever malicious program is being executed on that machine, it's throwing out communications to 8.8.8.8 to mask its actual exfiltration. So what we're probably looking for is a different IP address that isn't Google's, which you can find right here, 18.217.1.57, and that's going to be our C2 server, essentially. That's actually exfiltrating the valid data that we want, which in turn is our flag, like I said. So we can easily throw that into the command here by saying, in addition to checking to see if the DNS query name is not empty, we can do and ip.dst or ip.source, because it looks like the back and forth exists. It doesn't matter which one you do, equals 18.217.1.57. All right, and we're just going to run that. And, well, there's your flag. And the reason why it didn't print out stuff on separate lines is because the base64 command ignores new lines. As you can see here, it's ignoring all the new lines unless one of the decoded base64 characters is a new line. So if we were to just run this without base64 tag D, you'll see that this is our flag base64. And once again, if we rerun base64 tag D, it puts it all on one line for us, which is pretty nifty. So we don't have to actually replace all the new lines with something or try to jerry-rig a way to print out all the base64 data that we want on one line so that we can then decode it. The base64 utility ignores the extra white space for us, so that's pretty nice. Anyways, our flag is DNS exfil for the win, deadbeat. So let's grab that, copy it, and submit. Alright, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.